Hi, welcome. In this video, I'm going to do a couple of problems about the normal distribution. Chapter 6 review, basically. And so these are, this isn't a full review of the concepts of Chapter 6, but really just to make sure we have an opportunity to review problem-solving methods. So we have the price of gas in Massachusetts is normally distributed with a mean of $3.58 and a standard deviation of 16 cents. And looking for if a gas station is chosen at random, find the probability that the price of gas is between $3.75 and $4. Okay, so we're going to use the two-bell method to explain the reasoning. So we're going to go ahead. The bell on the left is going to be the X bell. It's normally distributed with a mean of 358 and a standard deviation of 16.16. Okay, and I guess it'd be good for me to let's put over on the side the formulas. There's two formulas for Chapter 6 from the formula card. One is Z equals X minus mu over sigma, and the other it's the same relationship, but with the X on the left-hand side, so it's mu plus Z sigma. Okay, so in this problem, let's go ahead and draw a picture of the problem, $3.75 to $4. So $3.75 would be to the right of $3.58. So that's $3.75. And then, so we're looking for the area of this bounded region between $3.75 and $4. Okay, so what we need to do, we're going to map this. We're going to transform the problem from the X world to the Z world, because then we can use our Z tables to calculate the value of that area. Okay, so this is standard normal. Okay, and we need to figure out what those two Z delimiting values are. And we're going to do that. We have an X and we want a Z. We have an X, so that's going to be an input, and we want a Z. So we want Z to be the left-hand side of the equation. So let's go ahead. We're going to have to translate two different values. So put the formula here. All right, and substitute in. So Z is equal to X, which let's call this Z of $3.75 is equal to X, which is your 3.75 minus mu, which is $3.58 divided by sigma, which is 0.16. Okay, and we need to get that to two decimal places because we're going to use it on for the Z table. So 375 and I'm getting 1.06 to two decimal places. Okay, so this one is going to map here to the left, the limiting value on the Z graph. All right, and now let's go ahead and transform the 4. So that's going to be 4 minus 3.58 divided by 0.16. And again, we need to calculate that to two decimal places so we can take advantage of the Z table. Okay, and I'm getting 2.63 to two decimal places. Okay, and that's here. So 375 went on the Z bus and came out as a Z score of 1.06, and 4 0.00 went on the Z bus and came out as 263. So to find the area of a bounded region, we're going to do 2 direct lookups and subtract. So let's go ahead and look these values up. A couple minutes here. So looking up the $2.63, 9957, let me check. Yes, so it's 0.9957. And then the area to the left of 1.06. 8554. And now we're going to subtract. Let's see what we get. 0.1403. Yes. Okay, and over here, this is the desired area. That is the probability that you randomly choose, if you randomly choose a gas station in Massachusetts, that the price of gas is going to be between $3.75 and $4. It's 0.1403. Okay. Okay, so the next part of the problem asks, for the same distribution, find the 60th percentile. So I'm going to draw a picture. We're going to use the 2-bell method again, where the left bell is, a mean of 3.58 and a standard deviation of 0.16. And then, of course, the right bell is going to be the standard normal with a mean of 0 and a standard deviation of 1. I'm going to draw a picture of the problem here on the left bell. So we are looking for that z-score, that value of x that has the property that 60% of the area is to the left of it. So let's go ahead. So we know at the center of the bell would have 50% to the left, and I need to make that bigger. So I'm going to draw the delimiting value over a bit to the right. So here is, the question is, what is the x value? So x equals the question mark. What is the x value that has the property that 60% of the area is to the left of it? Okay, so we're going to come on over and draw the picture when we're doing percentiles. And I guess one of the things I want to say is we always use the term percentiles are left tails, and that's why another way of thinking about why we're shading to the left here. Okay, so when we're doing percentiles, what we want to do is we want to start by finding the percentile here over in the Z land. And then once we get the Z, we're going to put that bus in the other direction to find the X. So the first thing we're going to do is determine what is the Z value that has the property that 60% of the area is to the left of it. And what we want to do is we want to go into your formula card, into your table. Okay, so I'm going to share my screen and pull up the formula card because I want to make sure that we all know how to find this value. This is Z value that has the property that 60% of the area is to the left of it. Okay, so we're going to go and look inside the formula card here until we get to a value 0.60. So these increase as we move to the right. And by the way, I jumped in on the right table because we had determined that this value is to the right of the mean, which means in the Z land that it's going to be positive. So looking in the positive part of the table, the right table, we're going to find two values that straddle 0.60. And I see here 0.587 and over here 0.626. Okay, I'm going to go put that up on the whiteboard. Then I'm going to circle the closest value. So two values that straddle 0.6, 0. 0.5987. And over here, the one next to it, 0.6026. All right, and it is that the first value was 13 units away from the desired area, and this one is 26. So I'm going to go with the first one. And now find the z-score. Look at the row and column that this sits in, and we have z equals 0.25. All right, so now we know the z-score that has the property that 60% of the area is to the left of it is 0.25. So we have a z-score. We want an x-score. We're going to use that second formula, and the bus, we're going to take this bus in the other direction. Here we go. So x equals mu plus z sigma. X equals, and here's our values. Here's the mu, here's the sigma, and here's the z. So 3.58 plus 0.25 times 0.16. Okay, don't forget, we need to do the multiplication first and then do the addition. I get 0.04 over here. This is supposed to be 3.58. That's my mean. Okay, and so then x is equal to $3.62, 3.62. Okay, so what this means is $3.62 has the property that 60% of the gas stations have gas less than $3.62. So the next part of the problem is to find the probability that a randomly chosen gas station has the price for a gallon of gas of more than $4.25. Okay, let's draw a picture of the problem. Again, two bell curves, X on the left, mean and standard deviation, given in the problem statement. Okay, and then let's get a Z curve here. Okay, so we are looking for a right tail, saying this is $4.25. What's the probability? What's the area to the right of 4.25? So what we need to do, we have an X value. We want to get a Z value. When we're looking for probabilities, we always do it in this direction. Okay, so let's go ahead and transform. So 4.25 minus 3.58 divided by 0.16, and we need that to 2 decimal places. Take a moment, work with your calculators with me, please. And I'm getting a 4.19, rounding to 2 decimal places. All right, well, I know from the empirical rule that means actually this value is probably out here, because we know that these points here where the curve comes close to the x-axis is about 3. Almost all the areas between -3 and 3 on the z curve. So I'm going to put it over here. And my question is that I need is how much area is to the right of 4.58. So we're looking for right tail. We're going to do 1 minus. So the area to the right of 4.58 is 1 minus the area to the left. Right tail, 1 minus a direct lookup. So I'm going to go ahead and look over at share screen and look over at the formula card. And we come down here and we see here that the largest z-score is 3.90. And over here, hopefully you'll open up your own formula card, but note the footnote says for z's greater than 3.90, areas are 1.0000, almost 1 to 4 decimal places, okay? So what we know is then this is 1 minus the area to the left, right? That's what we have. Oops, okay. And so that's really 0. We can call it 0 to 4 decimal places. I also often use almost 0 as another way of indicating that it's so close to 0, but logically it's not 0 because, you know, the normal distribution curve gets closer and closer to the horizontal axis, to the x-axis, without ever actually touching it. Okay, so almost 0 is the answer. Again, you could also write it like that. Okay, so those are your basic problem solving types for your normal distribution or your chapter 6 problems. Let me know if you have any questions.